Since Kepler we know that the planets move on elliptical orbits. In the 19th century it was also recognized that even the planetary orbits rotate. Classical physics had no explanation for this. Therefore, this phenomenon has been called anomalous perihelion advance. Planet Mercury has largest shift. In the century its orbit shifts by 43 arcseconds. This is tiny and practically insignificant, but any advanced theory of gravitation should support this advance. Newcomb suggested minor correction of Newton's law of gravity. However, it was just an empirical formula. Of course there were also theoretical considerations. But in the end Einstein's theory of general relativity won. But before the physicists agreed with Einstein, they should actually accept his special trick. In his calculation he used the planetary time. At least that's strange. The equations of motion are determined relative to the center of gravity of the Sun-planet system, but time is read by Einstein from the planet's moving clock. According to the special theory of relativity, the moving clock should be slower than a stationary clock in the center of gravity. The difference for the time intervals is exactly determined by the Lorentz factor. Thus, the possibility arises to make the calculation without the relativistic mass that a moving planet should actually have, when the time is read by planetary clock. Such calculation gives the displacement for the Mercury orbit of 43 arcseconds in the century, which exactly corresponds to the observing value. This perfect match was obviously very tempting for physicists. And nowhere is it mentioned that general theory of relativity completely renounces the relativistic mass of special relativity. But what about the huge mass increase in the particle accelerators? Is it making an exception for the planets? Or maybe it is tiny and therefore is not considered approximately. In the right part, Professor Schnitzer from the University of Graz has made classical calculation, but with the consideration of relativistic mass. Out came 7 arcseconds in the century for Mercury orbit. That's a sixth of the observational value, not a little. Approximately the same amount should also be added to a relativistic calculation and corrected accordingly from 43 to 50 arcseconds. Using 2 different frames of reference, one for locating and the second for timing, is basically an unreasonable arbitrariness. Nevertheless, Einstein took this step. His reasoning was: the law of areas is also accurate and the magnitude of second order, when one uses the period of the planet for the time measurement. Kepler's law of areas is a special case of the angular momentum conservation law. If Einstein had done the right thing, it would not only cause the Mercury orbit to spin too much, but it would also violate one of the basic conservation laws. That his general theory of relativity actually belongs in the trash bin would be obvious in this case. Einstein could somehow be understood, he wanted to make it to the top at all costs. The only question is, why was there no judicious review of his work at that time? And much more, why do the physicists still consider his foisting legitimate?